Hello everyone, this is Gunesh. I'll be talking about data exfiltration by third-party tracking scripts. This is a collaboration with Steven Engelhardt and Arvind Narayanan. Almost all the websites you visit today embed some trackers, including the website that you provide sensitive information to, such as your banking credentials or your credit card details. So third-party scripts embedded on these pages may or may not be able to read the page contents depending on how they are embedded. If the third-party scripts are embedded using iframes, they may be isolated from the rest of the page, so they may not be able to read, for instance, the passwords or credit card information that you provide. However, if the scripts are embedded using this script tag, they are not isolated from the rest of the page, meaning they can have full access to the page contents. So in this study, we want to answer this question: are third parties abusing their privileges to exfiltrate sensitive data? And we want to study these privacy implications of this. And we studied this in the context of three attacks: whole DOM exfiltration, misuse of browsers' built-in login managers, and exfiltration of social data. We developed a bait technique for this study, which consists of injecting sensitive user data into the context of real pages and monitoring access and exfiltration of this data by third parties. We built this on top of OpenWPM by extending its instrumentation. Using this tool that we developed, we crawled home pages and 5 random inner pages of 50,000 websites. So for the 3 individual measurements, in total, we crawled 900,000 web pages. Code and data for this study is available on this page if you are interested. So the first attack that we study is whole DOM exfiltration. So to analyze user interactions, what's called session replay scripts collect entire page content or entire DOM and mouse movements and key presses. So the session replay scripts basically record users' browser sessions in such great detail that marketing material from one company referred this as if you are looking over the visitor's shoulder. A demo of what these session replay scripts are capable of is provided in this URL. It's really eye-opening. I would definitely recommend you to watch it and see how a live recording, live visit by a user can be monitored in real time in this dashboard of this session recording website. So the problem with the session recordings or session replay scripts is they require a lot of data to accurately reproduce the user's interactions with the web page on their dashboards. So they require full page source and text, mouse movements, clicks, scrolls, and key presses. So this is how we detected session recording scripts. So the scripts would read page's source and send it to their servers. This is necessary for them to reproduce these browsing sessions. So we injected a unique identifier into the DOM. So the scripts read this the page source, including our identifier, and would send to their servers. And we basically inspected network traffic and looked for this unique identifier that we injected. However, we found that some third-party scripts, some session recording scripts, compress the data before sending. So basically, they compress the payload because the payload is really so big that this is kind of like optimization that they use. To detect such cases, we appended a data chunk into the DOM and compared payload sizes from 2 visits. So one with the appended, one with the chunk appended, and one without. In addition, we collected JavaScript stack traces whenever access to page source happened, like access to DOM, and we monitored event listener method, calls to event listener, to know which scripts listen to mouse and keyboard events. We also collected HTTP request and response data with the associated stack traces to find out which script initiated a given HTTP request. And when necessary, we did manual analysis and debugging for confirmation. So we found that sensitive data, including passwords, credit card details, student data, health data, and purchase details, leaked to these session replay companies. This was almost in all cases, this was inadvertent collection of this sensitive data. And these are the companies that we found to use whole DOM exfiltration. Most of the companies use that for analytics or advertising. However, in a few cases, translation libraries also collect whole page source, whole DOM. We found that session replay scripts have some automated redaction rules to exclude sensitive data such as passwords or credit card numbers from their recordings. We analyzed how these reductions work and found that there are, in many cases, they are very fragile, which is confirmed by our finding that in certain cases, such as Propeller Ads website, passwords that you enter into the login form would lead to this session replay company if you use this show password feature. So basically, when you use this show password feature, the automated redaction rule will not apply to this element, and the password will be scooped up in the recording, as we display here. In addition, we found credit card details leaking to session recording companies. In this case, for instance, the website uses a markup that the session recording company did not have in their automated reduction rules. So again, another example of how these automated reduction rules are fragile and sensitive data ends up in the recordings. Some session recording companies also offer a manual reduction feature that as a publisher, as the website owner, you may exclude certain elements from recordings. However, we found that this is also like a very fail-prone. On Walgreens website, for instance, doctor's last name and user's last name is redacted. However, prescribed drug name is leaked to the third party. We found that session replay scripts are very prevalent. Almost 10% of the top million websites include scripts from session replay companies. However, we found evidence of recording on only almost like 8,000 websites. But this is likely a lower bound because most session replay companies offer a sampling feature. That is, since the recordings takes like so much space, they allow websites to sample their visitors, only record a sample of their visitors. And by just manually reviewing 30 websites, we found several critical PII leaks that I gave examples of. The second attack we study is misuse of browsers login managers. So these built-in login managers help you remember your usernames and passwords, and this is the opt-in feature. So whenever you register or sign up for a website, the browser asks whether you wanted to remember these credentials or not. And next time you visit this website, it would autofill your credentials, the login form. So this is a really like in terms of security, great feature to prevent reuse of passwords across websites. However, these login managers do not check when autofilling your credentials. They do not check if forms are visible or not, and they do not record user interaction with the form, and they don't display any visual notification or indication that they autofilled your credentials. Basically, they allow an attack like this. The user goes to a website, signs up for an account, and saves the credentials in the browser's login manager. And in a different session, user visits another page on this website. This time there's a third-party script that wants to exfiltrate or read and exfiltrate users' credentials. So the third-party script injects an invisible login form. Browser autocompletes users' previously saved credentials. The script reads and exfiltrates user credentials to their server. A demo of this attack is given on this web page, so you may check how your browser behaves and whether it is safe against this attack or not. We use Firefox's NSI Login Manager interface to programmatically add users' credentials for each website that we measured. And we use mutation events, DOM mutation events, to monitor insertion of forms, like login forms. And we also monitored reading from form elements, like input fields, for instance. In addition, of course, like we also monitored HTTP requests and responses, including the post payloads. So we found two scripts using this technique to misuse browser login managers to read and exfiltrate users' credentials. The snippets from their scripts are given here. Basically, they do what I described in a few slides back, inserting an invisible login form and expecting the browser to complete it and then reading it. We found that, so the first company, AdThink, present on more than 1,000 websites, sends the different hashes of the email address to their server. And in addition, they send the MD5 hash of the email to a data broker, like major data broker called Axiom. Their script included very interesting and intrusive profile categories, such as hair color, eye color, education, occupation, and insurance state, card risk, and including like a dating status. And the second company called OnAudience or behavioralengine.com sends the hash of the email address to their server along with the browser fingerprint. And they were mostly present, the script was mostly present on websites with Polish country code top-level domain. And the second script was actually when we inspect the marketing materials, we found that they offer billions of user profiles for sale. So the last attack that I'm going to talk about is exfiltration of social data. So many websites offer login with Facebook or other identity providers such as Google or now Apple, and this makes it easy to authenticate users into your website. So the attack we consider here is the user allows the first party, the website, to use their social network data to log into the website. So basically, the first part of the website receives users' maybe public profile and email address, explicitly given permission by the user, and so it just makes it easy to log into the website. However, if there's a third party embedded in this website, this third party script may also have access to the Facebook data that is just authorized by the user to the first party. And the third party scripts may read and exfiltrate this user data to their own servers. To detect such cases, to detect this attack, we basically replicated Facebook SDK surface, especially the scripts, the functions, like methods that are relevant to logging in and querying of personal information through the Graph API. Again, we monitored function calls, stack traces, and HTTP requests to attribute correctly the attempts to read and exfiltrate this information. We found that 7 scripts use Facebook's API, collects Facebook data, and which includes email, username, gender, but most prevalently user ID. So most of the scripts, like 6 of the 7 were actually requesting the user ID from the SDK. Okay, so this user ID is not a global ID, global Facebook ID, but it's rather scoped to the application or the website. Okay, so it's like local ID. However, at the time of our measurement, there was a Facebook interface which you can take this app scoped ID and convert it to the global ID. Okay, and in 3 of the 7 cases, actually 3 of the 7 scripts, we could not verify the sending of this data to their servers. So we could verify that they were reading these identifiers, but in I think in all cases they were like heavily obfuscated that we could not verify the sending of the data. So how do these scripts use this data? So 4 of the 7 companies advertise themselves as customer data platforms. So they say they help publishers to monetize their users. Further says they use this identity data to prevent fraud. And Augur is a cross-device tracking company, and Nativka is a Russian company offering content monetization and traffic growth. So all these 3 attacks, actually we published our findings about these attacks in 2017 and 18. And of course, like when possible, we notify the affected parties before disclosing our results. So this gives us an unusual opportunity to look into the effects of our study this large scale analysis of these vulnerabilities. And this is partly helped by the press coverage that our preliminary publications received. And we basically compiled this list of fixes deployed by browsers, block lists, third parties, and first parties in our paper. So we are encouraged by the fact that Safari and Brave now require interaction with the form before completing the credentials in their login managers. And Chrome and Firefox are considering similar restrictions. Block lists such as EasyList, EasyPrivacy, and Disconnect edit some of the third parties that we detected in our study. AdThink and OnAudience, the 2 third parties that were misusing the browser's login manager, they stopped using this technique immediately after we published our findings. And we helped FullStory, one of the session recording companies, to fix a bug that was causing passwords to be leaked. Facebook, 1 day after our publication of our preliminary findings, they made it impossible to convert these app scoped identifiers to global identifiers. And SmartLook and Yandex, two session recording companies, they switched to using HTTPS on their dashboards. They were previously using HTTP, so like all the session recordings, they were not only collected but also displayed over insecure URLs, websites. In addition, first parties like websites using session recording, including Walgreens, Bonobos, and GraceSwap, really large-scale, like high-traffic websites, they stopped using these session recording companies. So the takeaways from this, the response to our findings is, although specific vulnerabilities that we report were largely addressed, the root cause of the problem still remain intact. That is, the same origin policy isolating scripts from the rest of the page is like all or nothing. There is no granular access. The trust is kind of assumed to be transitive. That is, when you trust a web page with your password, you're also implicitly trusting all the third parties loaded on this page. And first parties who may want to actually replicate the functionality provided by these third parties really lack resources to do so. Like, it's very difficult for a first party to develop an in-house solution for, say, session replay. So to wrap up, we studied the risks of including third-party scripts on web pages on a total of 300,000 pages from 50,000 websites. And we found highly invasive practices, including exfiltrating whole DOM that leak passwords, health conditions, credit card, and student data, inserting invisible login forms to trigger browser login managers and capture users' credentials without them knowing, and tapping into social APIs, specifically Facebook APIs, to exfiltrate users' social networking IDs. Although our preliminary publications helped address specific issues, the root causes of the problems remain unaddressed. So that's all I have. Thank you so much for listening, and I'm happy to take your questions.